Lesson 8.6, Law of Cosines. Today our objective is to apply the law of cosines. So on your note packet, you had a few more of these to look at. I like to focus on the first one because it reminds us of Pythagorean theorem, so that's why I have the others covered up. C squared equals A squared plus B squared reminds us of Pythagorean theorem, and then we subtract 2 times AB times the cosine of C. So we're going to practice using this formula on different kinds of triangles. And notice the triangle in the picture is not a right triangle, so the law of cosines will work on any triangle. The law of cosines is useful for finding the third side of a triangle when you know 2 sides and the angle between them. So it has to be an included angle. It is also useful for finding angles of a triangle when you know all 3 sides. So let's look at some of these examples. Here we have an included angle, and we're trying to find the side that is opposite the included angle. So I have color-coded. So angle 40 has a side opposite, which is A, and then 32 and 21 are surrounding the 40 degrees. So here is the law of cosines. And they have A first, B, and then C, which is the exact same thing as we had over here. It's just that C is first. And C isn't important because there is no right angle, so A, B, and C are just legs. So I put A here, and that's the important part. A is opposite the 40 degrees, so these two have to be in a specific location. The 40 degrees has to go where the angle goes, and that's where my pen is. And then the A has to go at the end, and that's the most important thing today. Then our 2 sides that surround the 40 degrees, they can go in for B and C, and then also for B and C here. So as we plug those numbers in, A is still unknown, B is 21, C is 32, times 2 times 21 times 32, cosine of 40. So then we're going to simplify. And this is where life gets a little tricky. You have to know how to run your calculator. In this example, all of the numbers are on the right side of the equation. So I could plug them all in just as it's written, but they simplified each one separately, which is fine. So they did 2 times 21 times 32, so that's the 1344, times the cosine of 40. So on your calculator, you could plug this line in, and that's equal to A squared. So then to get rid of the square, we have to take the square root of both sides, so we get 20.87. And that's how long side A would be. So let's try an example together. Here's our picture. We have 19, 23, and 27. We know all 3 sides. We have to find angle A. So I marked angle A. And opposite of angle A is 27. So those are important numbers. So what that means for us is that we have to plug them in here and here. So A is going to go in for the angle, so that's what we don't know. And then 27 has to go in for the A squared. So when we do that, this is what it'll look like. And then the 23 and the 19 go in for B and C in any order. So then minus 2 times 19 times 23, and the thing that we don't know is this A. So then we can simplify those numbers. And this person did them all separately, so 2 times 19 times 23 is negative 874. And then what we're going to do is isolate the cosine. So this one is a little bit different than the other one. So see these numbers? We have to be careful in how we move them. So what we can do is simplify these 2 numbers because we're just adding those 2. So they make the 1465. But you need to leave the 874 alone because it's connected by multiplication to the cosine. So then what we're going to do is we'll subtract the 1465 from both sides, and that's how this one becomes negative. And then once that piece is gone, then we have negative 874 cosine of A. So then I'd have to divide by negative 874, and then that is going to make the number on the other side positive, because a negative divided by a negative will be positive. And then if we put that on the calculator, we want to do the inverse cosine. So to get rid of cosine, we'd have to do the inverse cosine of both sides. And then that's where this becomes the 73.38. So if you didn't write that one down, that's okay. Let's try one of these together. Example 3. For triangle ABC, the length of C is what we need to find. We're given 17, 26, and an angle of 124. Draw and label the triangle. So we're going to use law of cosines again. So our important numbers are the C and the 124. So we have to make sure that those numbers go in here and here. So to copy this formula with our numbers, I'm going to write down C squared equals, and then the order of 26 and 17 doesn't matter. So I'll just start with 26 squared plus 17 squared minus 2 times 26 times 17 times the cosine of 124. So remember, the C and the 124 had to go in certain spots. Now, I put parentheses in here. If you wanted to, you could have just have times symbols. So now we want to work on simplifying. So I would suggest doing these two numbers together and then those three numbers together. So when I simplify, these two numbers give me 965. 2 times 26 times 17 gives me 884. And the rest of it I just bring down. So here's how that would look on my calculator. The next thing I'm going to do is from left to right, because all of these are numbers, I'm going to plug that on my calculator. And I get 1459. So now, C squared equals 1459.3 yada yada yada. So to get rid of the squared, I need to take the square root of both sides. So notice how I left that number on my calculator, and now I'm going to take the square root of that answer. So on the calculator, make sure you use the square root of the A and S, so it'll take the square root of the answer on the line above, and I'm getting 38.2. Let's try another one. For triangle ABC, find A to the nearest hundredth. So again, I'm just going to highlight the 115 and the A, because those have special spots to go in. So my A goes at the end here, here, and then my 115 will go in here. So then you see I do the cosine of 115, and then my A is here. So 42 squared plus 53 squared minus 2 times 42 times 53 times the cosine of 115. Now if I have to decide how I'm going to go through this, I could just throw everything on my calculator, but I like to do piece by piece. So I'm going to do that piece and this piece separately. So here's some of my work on my calculator. 42 squared plus 53 squared is 4573. 2 times 42 times 53 is 4452. So then I put those numbers in. And now I can do some more work on my calculator. And like I said, I can put it all in, and I get 6454 with a decimal. So then that 6454 is equal to a squared. So then to get a by itself, I have to take the square root. And that gives me the 80.34. So nearest hundredth means 2 decimal places. Number 2, find C. So 135 is the angle, and the side opposite is C. Why don't you try setting this up on your own? Please pause the video till the students are ready. Here's what your equation should look like. And of course your 8 and your 15 could be switched around. So now I like to simplify a little bit. So I'm going to simplify those 2 numbers and those 3 numbers. So then this is what my calculator gives me, the 289 and the 240. So in my equation, it looks like that. And now from left to right, I can simplify on my calculator. And I did it in 2 different steps. I did the 240 cosine, and then I did 289 minus. So that's just another variation to how you could do that. So we're getting c squared equals 458.7. And then to get c squared by itself, we take the square root. And we're getting 21.41. Please pause the video so the students can finish copying what they need. Try this question completely on your own. Go all the way to an answer. Pause the video till students are ready for the answer. Here is the solution. And remember, 26 and 22 could be switched around in order. You should still be getting the 1160 and the 144. Question number 4. First, we need to draw a triangle, label A, B, and C. So please put in the links. Check your answer with me. So here's what you're looking at. Lowercase b has to be opposite side B, or angle B. Lowercase c has to be opposite angle C. And the 29 degrees is included between those 2 sides, and the side opposite 29 degrees is x. Please pause the video while the students work on this problem. Here is the solution. You will now want to watch part 2 of 8.6 to see the next type of problem. This concludes part 1.